So, would you like to say a few words from our sponsor? Well, our hosts, who very kindly provided the venue and the drinks.
Thank you.
Take the floor.
Thank you.
Sorry, let me.
So light into the world now. So my commitment to you is that I will be the shortest speaker tonight. And I will also probably say the stuff that's of least interest to you, but I'm going to do it anyway. So thank you and welcome for coming. And I just wanted to say a few words about Critical Blue. I make a general assumption as I travel the world that people don't know anything about Critical Blue. So I'll put that right. So Critical Blue, we have a long history in doing obscure things with binary level dynamic analysis of software, which usually puts people to sleep. But most recently, we've been focusing on mobile platforms and in using some interesting new techniques to be able to do software authentication to identify mobile apps in the wild. So what that means is that the ability for a server who's interfacing with mobile devices and mobile apps to know for sure that the traffic that it's seeing is actually coming from the mobile app that they think it's coming from, and that the mobile app has not been tampered with in any way. And that's a major step forward. I won't bore you with all the ways in which people try to do this today, but it is a major way forward. We do it in a way that doesn't require any embedded static secret that can be extracted out of the mobile app. So it's very clever. It's deployed. We have real customers using it. It's all good stuff. What we're now looking at is how we migrate this into the world of IoT. And today, two of our very smart and much more interesting presenters than me will talk about what we're thinking about doing. So one of the things that we'd love to get is lots of feedback from you guys as to what you think about what we're doing and where you think the kinds of ideas we've got could be applied. And with that, enough. Thank you very much.
So Martin Hoxie, is that how I pronounce your second name?
Hoxie.
Hoxie, yeah, right. So as you can see on the deck here, Martin's going to talk about Google Analytics of things. So and what we'll do is we'll do a brief Q&A at the end of his talk, and then we'll transition straight to the next talk, and then we'll do a 20-minute panel Q&A at the end. So if you have any burning questions, go ahead. Other than that, we'll have a sort of more discussional type Q&A towards the end.
Thanks, Simon. So, as Simon mentioned, I'm going to talk about the Google Analytics of Things. Just out of interest, are any of you using Google Analytics with IoT devices right now? Oh, that's okay. So hopefully this won't put you to sleep, Simon, but perhaps you'll learn something. So my name's Martin Hoxie, and my day job is actually a membership organisation called the Association for Learning Technology. So this has nothing to do with my day job, but I put up my business card anyway, this is actual size, just to fit the job title in. We're quite a small organisation, so I end up doing quite a lot of the jobs in there. As part of what I do in the day job, it links into I was very fortunate a couple of years ago to start using a product called Google Apps Script. And because no one uses this product, Google actually corralled me into a very special group of Google developer experts. So if you're using Google products and you're quite good at that, there's an opportunity to come together with other experts not employed by Google and learn more. So as part of that program, I had an opportunity to speak to Google Analytics experts, and there's a couple of them here. Interestingly, Google have just extended the program to IoT. So if you're doing stuff with Google products in IoT and you'd like to be become a Google expert in this area, then have a word with me afterwards. So a lot of this presentation is actually based on the work a guy called Nico Michelli's done. So Nico's based in Philadelphia in the States. And he's really explored what you can do with Google Analytics beyond the kind of simple web page tracking. So all these people are very contactable, so, and they are the real experts in this. So if you want to follow up on any of these things, I'm more than happy to put you in touch with them. So in this talk, what I'm going to do is I'm going to very quickly just introduce you. Hopefully, you already know a lot about Google Analytics within web tracking, but then we're going to go into what's actually further possible beyond that. So, you know, in the beginning, it was all very simple. You know, when we had HTTP and markup, there wasn't really much interest in doing anything beyond, you know, measuring what was happening, what pages were being viewed, and what links were being clicked upon. But since then, you know, a lot of really cool frameworks have come out that just completely changed the web experience into a full-blown web application. In terms of tracking this, you know, Google Analytics has evolved as part of that. So I'm sure, are many of you web developers in your spare time? Yeah, and many of you using Google Analytics to get some data back. So you know about, you know, hooking into events on the page, you know, dynamic loading of content, buttons, and so on. As tracking's got, as web development's got more advanced, so is Google Analytics. So a lot of people, when they think about Google Analytics, they think of it as just a way of analyzing web pages, but it actually goes beyond that. There's a lot you can do in understanding engagement. So, and there's obviously lots of other products that are out there that do that. One person. So good. I get another talk where I've got a room of people to educate and entertain. What the Google Analytics measurement protocol does is it removes the requirement for JavaScript altogether. And it basically provides a very basic API for you to start sending data into Google Analytics. So all you need to do is make a HTTP request to the Google Analytics measurement protocol. So this can be GET or POST. So, you know, there's all, you know, the majority of programming tools that you're already working with will make a request like that into there. This opens it up. So, you know, it's no longer just web applications, it's the whole gambit. You know, you can do this on smart TVs, kiosks, anything that has an internet connection can potentially be sending data into Google Analytics. And there's a couple of things I think worth highlighting about this that can actually take this concept even further. So looking at some of the possibilities, so this was something that Nico Michelli, who's one of the Google Analytics experts, put together. So he's just got a Raspberry Pi, a couple of sensors on that. So he's tried things with motion sensors, with light sensors. So very basic kit. And what you can actually do is, with a couple lines of code, this is Python code, you can actually send, this is an example of a motion sensor. You probably might not be able to see it in detail. But essentially with a couple lines of code, all we're doing is making a URL request and sending data into Google Analytics. In this example, all he's doing is whenever the motion sensor is detecting movement, it's sending a hit into Google Analytics. So that comes with some useful features. So you don't have to worry about creating dashboards to quickly look at this data. You can use the built-in things. So here's the example Nico did of using his motion sensor to actually detecting his sleep patterns. Obviously, there are lots of other ways that you could solve this problem. So let's see how we can actually take it a bit further to make it a bit more practical. So obviously, with your Internet of Thing device, it might not always be on the internet. You don't want to constantly be calling up Wi-Fi. So you might want it to be offline, working away in the background for a bit, and then come along online every couple of hours or so. So what the measurement protocol has within its specification is something called queue time. So basically, you can have your device sleeping for 4 hours, and then when it wakes up as part of another process, you can start actually pushing data into the Google Analytics with a queue time, which gives you an offset. So even though you've come back online 4 hours later, you can actually give reliable timings of when events have actually happened. The other thing you have is batch. So you might have had a number of events happening in that 4-hour period. What the Google Analytics measurement protocol allows you to do is actually send batches of data. So it's limited to 20 hits, but you can hit the batch protocol a multiple number of times. So it might take you a while if you've got a big queue of data to get through it, but it's another way of approaching the problem and potentially getting information off your device into Google Analytics. So looking at crossing the divide. So if you've done stuff with Google Analytics before, one of the things that you may have spotted within the terms of service is you can't actually send anything that's identifiable to a user into the Google Analytics data. So things like names or email addresses, not allowed. And if you're caught doing that, you potentially get your account killed. What Google Analytics does, however, provide is within the both the web version of Google Analytics, so the universal analytics, but the measurement protocol as well, is the ability to send in a user ID. So this can be a hash of an email address. So it can be something that you've already got logged within your system. The really interesting thing about this is you can actually use client IDs across web to your device and so forth. So if you're starting an interaction with a user using a web interface to initialize an IoT device or interact with it, you can actually send in the same user ID into that data, and that gets aggregated within the Google Analytics reporting. So you can see flows of a user going from the web to how they're interacting with your device and wherever they go after that, as long as you're using either the Google Analytics measurement protocol or the web tracking. So the other thing to just note on here, you might not be able to see, is when you're using Google Analytics, is you have a tracking ID. And the tracking ID you use on your web sites is exactly the same as the tracking ID you use in the measurement protocol. So again, we're getting continuity of data across platforms and devices. So let's have a look at a couple of other examples of how you might be able to do this. So this is an example of a friend of mine who's published a number of different libraries, and actually he uses Google Analytics to check when people upgrade their library to the latest version. So he's just using standard Google Analytics reporting to see when something happens. So in this particular case, one of his previous versions of his libraries was going to break, so he needed to move everyone onto the new library, and he could actually monitor whether that was happening. Within IoT and security, it might be the fact that you want to send data back about if your device is being attacked. Again, you could log connections to your device that are trying to probe it for weaknesses, and you can get that back into Google Analytics. If you've played around with the Google Analytics reporting, you also get real-time reporting. So again, with the measurement protocol, you can see all this happening in real time as well. So within the measurement protocol and web tracking, there's lots of different hit types you can use. So it's not just pages or events. You can go into e-commerce side of things. It'll also do exception tracking. So if you're trying to log errors in your script or errors within your device, there's actually a dedicated hit type that you can use. So within Google Analytics, obviously it's not going to be the solution for everything. You're still constrained by what you can send back in terms of hit type data. But it's not always just sending back one hit. So you can send back integers, if you've got multiple hits, or for commerce, if you've got multiple values, that can be included in your data. I've mentioned a couple of times the inbuilt reporting. If you haven't looked at Google Analytics recently, there's an ever-growing palette of tools that you can use. So you can actually get some, I think, very useful event flow, funnel information that you can actually use to look at how people are interacting with your devices, how they're using your devices. Really, it's trying to get some sort of actionable insight from the data that you're collecting so that you can improve what you're doing. Within Google Analytics, there are actually APIs for reporting as well. So you don't have to be restricted by what Google presents you as a dashboard. This allows you to do more automated stuff in terms of reporting what's going on. Allows you to customize the way that you're presenting that data, and you might want to connect that data with other sources. So, for example, when I mentioned that you can get the user ID and the client ID, there's an opportunity to get that data back out of Google Analytics and actually match it with a person. Because whilst you've sent anonymized data in terms of, or semi-anonymous data in, once you've got that data back out through reporting, you can do a lookup. And there's lots of, I think, increasingly easy ways to start creating your own custom reports. So within Google Sheets, there's an add-on now for Google Analytics. So it's a really quick way of just creating very simple reports that for the dimensions and metrics that you're interested in. This was an example I produced of a script that you can configure to grab data out of Google Analytics and actually send it off as emails and CSVs and other formats. Google Analytics also has a product called Super Proxy, which allows you to do something similar. So again, it allows you to distribute data to people that might not necessarily want to have access to your Google Analytics reporting via the website. And something else that's come out recently is Google have a data studio. So again, this allows you to integrate with Google Analytics and other data sources and start building up pictures of what's going on. So that was kind of a whistle-stop tour of what's possible within Google Analytics and the measurement protocol. So hopefully it's inspired you to go off and have a look at what's possible in the documentation. And now that you know what is potential, what is possible, hopefully you can get creative and have some fun and slide down the stairs.
I have a question. You said that the data is anonymized and Google will slam you for it
Yeah.
if you break it up. In my experience now, there's no such thing. One way or another, data can be joined up somewhere. So, even on anonymized devices, how do you get user consents for tracking data? And
Yep.
what is in Google Analytics to specifically stop that and stop it from being joined up down the line?
There's nothing in Google Analytics to stop it being joined up down the line, and I think it's really up to developers to make that an option. So obviously with the web tracking, you can use things, ad blockers that prevent you from having your data collected into Google Analytics. With the measurement protocol, there's nothing stopping that. So I think it's very much up to how you're designing your devices and providing that opportunity for people to consent to actually allowing data to be collected. And I think the important thing is it's, as far as possible, informed consent, because quite often we get these screeds and screeds of terms and conditions which no one reads. But I think I think in terms of best practice, it's putting something like that to the very top, a very simple button. Do you want us to allow tracking or not? And a choice between buttons. But I think it's a very good point.
I think it's one of great concern, especially with consumer products like, let's say, LG televisions
Yeah.
and so on, tracking when users are at home.
Exactly.
Doing in
Yeah.
China.
Yeah.
at the moment.
Yeah.
People don't know that. So they can tell when houses are occupied. And
Yeah.
don't enjoy it.
Yeah.
Do Google charge for this?
No.
So what's in it for that?
The data.
They must be able to do. What can you do with the data? If you take around a key product?
Within IoT, I don't know what they're getting from it. With web, it's it's ads.
So why are they moving into this area? What's in it for them?
Well, it's a very good question, and I don't think I have an answer to that. But increasingly, I'm seeing, the bar being, within Google Analytics, there is a premium service which allows you to send more volume of data into Google Analytics, and I increasingly see the threshold between the free becoming bigger and the premium smaller. Increasingly, I think they want more and more data, and they want to remove the hurdle even more to get it.
We like talking about security and privacy in this group, don't we? Do you want to add to that?
Yeah, I think they might not know exactly what they're looking for, just they won't have the opportunity to look for it in the future. And because that's the big data thing. No one knows what's at the end of the rainbow. So just the more data you get, more things go
More
to
is
the
better.
future.
Yeah. And okay. So I was being marginally flippant about, did you understand that? Because it is always very difficult for me to understand from those who attend how deeply technical the talk should be. Because there are certain people who are more interested in the business applications or the general sort of strategic direction of how IoT can be applied to industry, their business, or maybe a project they're working on, a smart home widget or whatever. So that's why I think it's quite nice to sort of mix it up and maybe do some events like this that are, I think, more technical than some of the others that we're doing. But I think it was a nice combination, right?
Hope so.
Would you understand? I mean, would you agree with that? Excellent. So I think if there are any other, maybe time for one more question before we go on to Barry.
One quick one. So you said that Google will put your account of your personal information in it, but why is it acceptable then to include, or essentially it's personal information like the user ID,
Yeah.
your own
Yeah.
way of identifying it?
I believe this is down to the Data Protection Act, because it's not sending, names and addresses. They get around data protection legislation.
So basically it's Google looking after their own back rather than trying
Yeah,
to,
yeah. They don't want to be a data controller.
Can I add to that? Because there's another
Oh yes.
Huge numbers of very important people do not understand it is in force. For those of you who still think it's coming into force next year, look at Article 99. It's in force now, and as individuals and businesses, we all have the right to say, no, you cannot use that
Yeah.
unnamed data.
Yeah.
If it pertains to you, you can stop it. At the moment, you can't go to the data protection registrar in any country and have something formally done about it. But it can walk into court and sue those if you really want to jump up and down and make an awful noise about somebody pinging your...
And I think that includes things like profiling. Am I right?
Yeah, well, profiling is a very interesting concept, which judges are having meetings about now to try and learn
Yeah.
what it really means. But it fundamentally means that you can put data entities of any size or type together in one way or another that eventually arrives at being connected with an individual, a data user.
Yeah.
Then there's a problem, and that problem can be stopped, can be broken. I just wanted to add to that.
Yeah.
That's what we do at IoT.
Yeah, that's a point very well made. So, yeah, let's configure the next deck. Why not another round of applause? Thank you. So we're mixing things up a little bit and confusing the people who are literally thousands from around the world who are watching the live stream as we speak, I'm sure. Richard was supposed to be the next speaker. He insisted that Barry should provide a more general overview, is that right?
Yeah, it's more sort of
Whereas
general.
Richard is
Yeah.
gonna get
Yeah.
slightly
And also I get Richard's audience then as well, you see.
and
good.
dirty,
Yeah.
more specific around the specific area of IoT security. So, round of applause. Awkward pause, blue screen.
Roadies.
Come on, chop chop.
Yeah, that's right. It's working. So present.
Times like this, I have to point at things as well.
Yeah.
Just
Slide it over.
point and look like a-
You need to grab the top of it.
We should get some interim sort of entertainment. Maybe I'll do a
There you go.
for you or something. Oh, here we go.
There we go.
Right, Oh,
Where's my notes?
sorry. For those that
What notes?
tweet and Facebook and LinkedIn and Face Chat and Snap, what's it?
That's right.
The hashtag is
Right.
IoTSCT,
No, you're fine.
IoT.
It's fine. It's fine. It's fine.
IoT or IoTEDI.
No, you're right. Oh, right. Okay. Yeah. Get the other one.
Yeah, follow us
Yeah.
on Twitter.
No.
IoTEDI.
There you go,
and we've got
perfect.
a new website,
Alright.
IoTSCT.com. Check it out. Wi-Fi, I'm sure there's Wi-Fi. Do you guys have data? I'm using my 4G connection. Are you able to access the internet? The interwebs? If you need to use Wi-Fi, I'm sure one of you
Yeah.
guys will be able to help you get on. What is the Wi-Fi? Is the password correct? I'm sure it is.
Yeah.
Are you able to offer that to our guests or not really?
I can't remember the password.
Best sort of password. No one knows it. Super safe.
If it's a problem, just dodge the question and move on rapidly. Right, over to you.
Okay, thanks. So what I'm going to do is very quickly introduce this idea of threat modeling. Has anyone heard of threat modeling as a security approach? Yeah. So very, very useful when you're at the kind of the design stage of your project. I would argue actually completely vital at the design stage of your project. Otherwise, you're going to have a lot of problems further down the road. So there's very, very sort of high-level introduction to what it is, how you might go about doing it, and what the benefits are, and what help there is out there
to try and help you along the way in what can be quite a large subject, but doesn't need to be. So sort of set the scene a little bit. Just so far this year, already IoT problems have been in the news, many different things. So the most recent one just last week was these Miele dishwashers, internet connected dishwasher, why not? Shouldn't be a big deal, but these are in hospitals. So if you can compromise this, you have control over the settings, so temperature. So if that's on a ward where you're doing infection control, suddenly you're not getting hot plates, and that's bad. More importantly, though, is once you're inside the network, if this thing's connected to an external network, you get inside the network, then you can start looking around for other things which are more interesting. Enter drug cabinet. So computer connected, hooked up to the, in theory, just the hospital intranet. So you're able to have prescriptions put in, you put in the patient ID, and it dispenses the drugs that patient needs to have at that particular time. All very good. 1,400 flaws currently in the in-circulation version of this, mainly because they didn't design an upgrade path for the Windows version. It runs Windows Server 2003. So yeah, that's not going to get fixed, and the only way to fix it is for hospitals to buy a new one for many, 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 many hundreds of thousands of dollars. What I particularly like is Cloud Pets. You can send messages to each other and talk to your children through it, and it's all lovely and things. Unfortunately, they used an out-of-date, unsecured MongoDB database in the back end, so that's been cracked wide open and exfiltrated lots and lots of email addresses of people and video and telephone conversations with their children and all these sorts of things. So big privacy problem with that one. And then another similar classic consumer problem is internet-connected webcams. Just a horrendously bad idea. These things are such mass market now that the bottom line is so difficult to reach that every corner is being cut, and the speed of trying to get new stuff to market is incredible. So the pressure on these guys is immense. So they're just entirely features, get out of the door, make sure it's got the functionality that you want. And these are rich trove for examples of exactly the things that can go wrong if you don't take security and do the threat analysis in advance. And in fact, if you look at what we'll look at is this top list of classic exploits that you see in different types of devices. These cameras tend to be full of them. Not just cameras, but also the internet web-based admin portals for them as well. It's truly horrendous. So the general reaction is when you start hearing all these stories is like, oh my God, these people, I'm smarter than these people. I would not make these mad mistakes. Now remember, these things are all designed by really smart people, really clever ones, many of whom have PhDs and stuff, and they still make these mistakes. Problem is the pressures, outside of just the direct engineering is there. You've got to get to market. You've got to have these features. We don't care if it's well tested. We don't care if it's all up to date. There's no money to do the maintenance patches and releases later on. You don't have a program for doing that. You don't have money for the servers in the cloud to distribute patches, all these sort of things. So even with the best intentions, you can very, very easily make mistakes. So the trick is to make sure that any security design you do up front is effective and rapid and as cheap as possible to save you trouble in the long run. So as Simon was saying, it's very easy to get very technical about this, and Richard will get extremely technical in the next presentation. But what I want to do is to alert everyone who's more on the business side of things that they need to know this stuff, at least at the higher level, or at least know to ask the questions of the people who are designing these systems, that they need to be thinking about these sort of problems. So in particular, once you have said, okay, guys, make sure you do a good security job on this, I want to see a threat analysis and figure out who's going to attack us, how they might attack us, this sort of stuff, they're going to come back and say, well, it's going to cost lots of money or take lots of time to fix this problem and come up with a fantastic authentication system, or we can drop the feature. Yeah. So on the business side, you're going to start making these calls in terms of the trade-off between time, money, and security. Also, our friend GDPR is there, of course. Thing I was surprised about is Brexit's not going to save us. So there isn't even one good thing. GDPR is beyond Europe, so any European citizens data which is held is under the jurisdiction of this. So, you know, Italy will come after you if you have Italians' data. So in particular, 2 articles pretty much mandate you have to do a security assessment up front, and you have to have that documented. And if you don't, they'll rake you over the coals if there's an exploit against you. And secondly, you have to have a policy on privacy and how you're protecting people's data. So you have to have these built in from the beginning in your product and your system and your business. It has to all be there. All right, okay, so threat modeling is quite a massive subject. We are only going to focus on a very small amount of it. So we'll quickly look at how to sort of think about the systems you're building. Mostly we'll talk about what can go wrong, because that's entertaining. And then a little bit about what you can do about these things, overlap. We won't look at this very, very hard and important bit at the end. That's for future reading for anyone who's interested, is how you actually figure out whether you found all the things you didn't know were there. Good luck. Okay, so what are you building? If you don't have this sort of level of data flow diagram for your product and system, then you're not going to get very far at the beginning. You must have this on a whiteboard somewhere already when you're doing the design. So the main things you want are kind of the external factors that are in orange here. So whether it's a mobile phone app, a web interface, your devices, your sensor kind of net on the side, and also in particular the roles of the different types of user you're going to have on the system, all the way up to kind of, you know, the supervisory roles, including yourself, about what you can access and these sorts of things. Also, you really want to pull out the sort of data in gray that you're storing, so where you're storing the data, and potentially, as you get down into more detail, the sorts of data you're storing, and particularly the reasons why. So all this stuff's good to start thinking about why am I keeping this, where am I keeping this, therefore what sort of security does it need. This is exactly the sort of stuff the GDPR is looking for. And then each of the sort of yellowy boxes, they're all about different processes and the data flows between them. So this is where there's actually being a transform to the data, or there's a service where it's, you know, generating data or collating data and sending it back to you. One of the main reasons why you want to be able to draw these sort of diagrams of your system, as well as just being able to design the damn thing to start with, is the idea of trust boundaries. It's a very, very important concept, because a trust boundary is where you there's an assumption about the data once it goes across there, or the services you ask out there, only certain people can access that. And on the other side, there's a different set of people who can access the things on the other side of that trust boundary. Trust boundaries are basically where the attacks happen, more or less. That's where, or more accurately, that's where you need to defend against attacks. There are 2 ways of thinking about it. You want to do your defense on the trust boundary, but an attack might traverse the trust boundary and pop up somewhere else in a different component beyond that trust boundary. Because typically an attack is they put some bad data in, and then along the range when it comes, you know, potentially it's going to go all the way and come all the way back out, and you've got a cross-site scripting attack. Yeah. So there's lots and lots of places where the actual attack can end up happening, but the defense point is your trust boundary. So there's sort of 2 ways you can draw these boundaries. Either it's fairly obvious in terms of the logical partitioning or the physical partitioning of your system. So it's a different machines, different network, different subnet, separate processes, these sort of things. There's kind of these natural boundaries happen. Or the other way, if you don't kind of know where they're going to be to start off with, if you're very early in your designs, you start thinking about the roles of people who are going to be interacting with the system, starting from, you know, the highest level kind of root authority, and you work backwards. And wherever there's going to be interaction with someone who has a lower level of authorization, then there's going to be a trust boundary happening there. So you have to identify that point, and you have to protect that and make sure that nothing can leak across that boundary. Right. So once you've kind of identified your system, and you know where the trust is going to flow, you know where the important things are kept, you can start thinking about how are people going to break into my system? What terrible things can happen? There's lots of ways of thinking about this. Like the traditional one is just to brainstorm, which is quite effective actually, just throw ideas, what could go wrong. Usually that's influenced quite a lot by what you've heard in the news. Another way of doing it, which is very popular, is to think like an attacker. And you just get your hoodie on and you think, I'm going to break into this. That's really bad because, well, at least some of you are not hackers. So you'll end up with a very strange set of motivations based, again, largely on movies. So a good way of doing it is one of these many, many mnemonics which kick around. So this particular one, Stride, is very straightforward and is quite effective. And just enumerating all the possible ways things could go wrong, applying that to your system, and then hopefully vulnerabilities start popping out and you can start addressing them very, very quickly. So first one, spoofing. This is where you pretend, an attacker pretends to be something that they're not. This is kind of the classic one, and it can happen at all levels. So on the outside, the most obvious one is you pretending to be someone else. So that could be a different user by stealing user credentials. Could be a more elevated user, maybe stolen admin credentials. But also if someone's already got into the system and they create a new process on your system and make that pretend to be your process and therefore access the data that only your process should be able to access. Same reverse as well. You can spoof a file so that you knock a configuration file out of the way, you load in a new configuration file, suddenly the system is in debug mode and you can access everything. Or you get rid of the passwords file, users file, and inject your own. You've taken over. So there's lots of different ways that spoofing can affect your system in many different aspects. Tampering is kind of the classic super nerdy one, because this is where you're actually modifying something which is happening on the system. And it's kind of more relevant to stuff which is in the field. So it's the device that you've got out there and people have got their hands on. They can put it in the lab and they start tampering with it. They start changing files, they start messing around with the memory, they can start pushing different things into the network. Quite often it's quite hard to actually do anything bad that way. Usually it's something much, much simpler. Usually it's something that somebody's forgotten to secure somewhere else is where they break in. Repudiation is actually more of a business level problem, ultimately. So this is where you say, I didn't do that, that didn't happen. And you have this question like, oh, how do you prove otherwise? This only becomes a problem if you're like, you're Amazon, and people say, well, I didn't buy that. And suddenly you've got all these returns and things. So the general solution to this is you log everything so that you can very, very clearly show, well, if you didn't do this, why did you log on here and do this and do this and do this and do this? You have responsibility for these things happening. So one of the other repudiation things, of course, is to attack the logs. So if somebody can get into your logs, they can start ripping stuff out and they can sort of start saying, oh, that never happened, I was never there, I didn't order that thing, I didn't trip that sensor, these sort of things. Information disclosure is the big one. This is where stuff starts leaking out of your systems and people can then start identifying other people, use the data to attack other systems, or use it for any number of criminal nefarious needs. Lots of ways things leak, usually the way you would least expect it. So kind of the obvious ones are databases misconfigured or uses default passwords, this sort of thing. You can just break in and get that sort of static data that's sitting there. But there's lots more subtle ones. Classic one often is you just start hitting URLs on with your web page, and eventually you start getting errors back. And if people haven't configured things correctly, that error will contain all the database tables, or all the user credentials, or these sorts of things. There's an awful, awful lot of vulnerabilities around that. The meal dishwasher one is a classic one, because that basically gives you the password table if you traverse back up the directory far enough. So there's all these sort of things, and it's the least thing you expect because it's the most natural thing in the world to kind of say, oh, I'll give a useful information in my error message because that's useful, and it's useful for the wrong things also. So we covered data stores are particularly bad. Usually it's poor access credentials being set up. A lot of these database things we just install will have quite sensible systems for managing the access to them, but they're often too complicated and often have bad defaults. So it's very easy to set it up in a way which is not secure to someone who's more familiar with technology than you are. A classic one also is cryptography keys. Lots of people use cryptography keys or special codes to protect various aspects of their system, and they just put them in a file there, unprotected. So then someone just says, oh, I can't read what's going across the network. There's the key. I've just decrypted it now. That happens all of the time. So it's a very, very easy thing to just fall over because you've thought about this part of the system but not that part of the system. Denial of service is a favorite one. So you always hear about DDoS attacks. We were talking about that at the beginning. And DDoS has become very, very fashionable in terms of it's like you get lots and lots of infected machines and you blat somebody's network interface and then they can't provide the service they're trying to provide. because of there's not enough space in the pipes. However, before DDoS there was always DOS, and there's lots and lots more nefarious kind of ones, and this will become increasingly important probably as firewalls get better and various networks get in place which can suppress DDoS kind of attacks. You get a higher layer in the network stack, and these tend to be more about complexity attacks. So these are attacks against processes or memory or data storage and these sort of things. So what you do is you find out basically a way to exploit a bug in a program which causes it to go into an infinite loop or causes it to kind of have to go and look up massive tables of data, and therefore it slows down the whole system, or in cloud times actually costs the company tons of money because suddenly it'll start scaling up and scaling up, scaling up. Suddenly your AWS bill is thousands and thousands of dollars. Personal favorite one, especially for IoT, has to be data store denial of service. So this is where you find some way of filling up the data store on a device in particular, which is probably quite limited, so that it has to basically die because it's got nowhere to put data anymore. And then maybe it'll panic and reboot, and it can't boot because its data store's full, so it can't actually move anything around to create temporary files, and you've completely trashed the device. That's surprisingly straightforward to do even by accident. Not that I've ever done that. And then finally is escalation of privilege. Basically what you're doing here is getting inside a existing process which is running at perhaps a higher privilege level than you are as a user or you're allowed access to, and then corrupting that in some way so that you can turn it to your own needs, and then create a shell or something at a higher level of privilege, and then use that to create another shell or another high level of privilege using various exploits as you go. So this is like kind of the classic thing when people talk about buffer overflows and stuff like this. This is the sort of thing they're trying to do. They're trying to start executing their own code in a different context and jump up the escalation. And as soon as you start jumping up, the privilege level gives you more and more access to more of the system. So you've done a great job in configuring all the layers of privilege in your system. It's all very well protected and partitioned. Someone starts leapfrogging up that, then you can't do anything. It'll just top over. This is the sort of thing which even happens in virtual machines and stuff. So you get people pop all the way up from a process to an operating system to a virtual machine into another operating system to another process. This is the big terrifying thing about cloud systems. So all that seems quite complicated, and even though it's kind of very fundamental about the sort of things you think about, it's often good to be able to get ideas about where you should be looking. Fortunately, there's these guys, the OWASP, Open Web Application Security Project, and they've been going for a very, very long time. Does people know about OWASP stuff? So they've been going for a very long time trying to secure the internet. And the sub-project has started, which is looking very much IoT. And what they regularly do is do forecast and do analysis of what threats are and emerging threats across the whole spectrum of internet stuff, and including IoT now. And there's a guy from Hewlett-Packard who's leading this project, and he's doing a very, very good job of trying to expand what was kind of a very server-side thing and make it more an Internet of Things thing, and looking at the devices and the communication as well, and doing the same kind of process. So I would definitely go and look at their wiki page. Very, very, very useful. Lots and lots of good ideas for testing your application, things to look out for when you're designing, all this sort of stuff is very, very nice. One thing they produce is a top 10. The last one was 2014. I think they're going to do another one this year, maybe. And this is like a big survey of all the exploits that have been reported to them, and they analyze them, and they come up with a kind of like a weather forecast. So the weather warning forecast, where as things get more and more red, as they get more likely and more severe. They do a similar thing for a top 10. We've only got top 5 here because it's 10. So immediately you can see the sort of stuff you'll see come up again and again and again in news reports about exploits. So insecure web interface, that's the typical one for webcams. Is not the webcam itself, but the interface you use to configure it. When you buy one, you log on and you create an account and all this sort of stuff. They're not well put together, generally speaking, because it's IoT guys, not web interface guys doing it. So quite often they're leaky, all sorts of problems. You can get all sorts of control with that. Then very closely related is the second one, is generally speaking insufficient authorization. So that's all interfaces facing the web, basically. Not enough protection to the APIs, particularly that these devices are using. Very, very common. What's often worse than those ones is that it's not so much that it's not protected, it's that it's protected badly. So you can see people have gone, oh yeah, we should do something about that. We'll just use this library. And they haven't quite used it right, or they haven't set it up correctly, or they've left the keys lying around somewhere. And it's very, very easy to exploit. Insecure network service is very similar again, but that's kind of the opposite way around, where you've got, rather than stuff you're using, stuff you're not using. This is a big problem for a lot of off-the-shelf operating systems. You bang it into a consumer piece of IoT, it's got everything open. So you've got your EPOS actually, point of sale terminals are the worst for this, open USB ports. So you can just stick a keylogger in. Hey. Passwords. So there's all these sort of things. So that's mainly what that's referring to. Lack of transport encryption. If you don't use HTTPS, please get off the internet. And then privacy concerns. This is all to do with database protection stuff, generally speaking. So this is like, have you done your ACL properly? Have you locked down your database? Or most importantly, have you only collected the data that you absolutely, definitely need to provide that service? This is the biggest mistake that people make, is they just sort of harvest all the stuff. You don't need to. Just take the few things you need and what you do have, anonymize as much as possible. And then generally you'll get past that. That's possibly the trickiest one to do, because it immediately bangs up against business concerns, because more data is better. Yeah. Right. So in conclusion, don't panic, but panic, because you have quite a lot of stuff to look at, and it's the bureaucrats are coming for you. So if you build this into your whole design process at the beginning, it's a lot less painful. You can just ask, take a day or two just to sort of go, okay, this is my system. Where are the vulnerabilities? What protections do I need? Do I need this many user rules or not? Can I collapse them in? Do we need this feature? These sort of things would make it a lot simpler. And there's lots and lots of projects. OWASP is one of them. There's many, many other research efforts into monitoring this stuff. Actually, Department of Homeland Security have industrial and IoT cyber protection directorate, and their site is brilliant, really good. So yeah, I'd go there, but then they'll just follow you forever. So yeah, but it's good tips. Okay, right. Thank you. There's some useful links, and also most of this stuff has been cribbed ones going over from this guy's book. If you're interested in threat modeling and understanding it, I would definitely recommend getting hold of this. It's very good. Okay, any questions?
This is more of a comment. Your early slide with the melee disinfection machine. Pharmaceuticals and healthcare are the most regulated industry. And I've worked with it for many, many years. And it's what has turned me grey. Now, the thing is that anybody who's involved in good manufacturing practice, GMP, has to basically record everything. So there's pressure on the user to do this, but at the same time, if Melee can see what people are up to, and they're not doing what they say they're going to do, then it just falls back into itself. Because in the early days it used to be called GAMP, Good Automated Manufacturing Practice. This is before, it was just to have some automated rather than a guy telling you piece of paper and pen. And so this has just become an absolute nightmare in the pharmaceutical industry, because people can check on whether they're doing what they say. And there is in any pharmaceutical plant one person, the QP, the qualified person, and their neck is on the line when they sign off that this product consider going on there. And these are the people who, well, I'm not sure there are that many out there who really understand all of this stuff. And if somebody dies because something hasn't been done properly, then and people will find this out very, very quickly. Because the news is now built on vaccines going wrong, or things like that. And the whole thing has just become an absolute nightmare. And the industry, in some ways, has only got its sandbagged
Yes.
into
Yeah.
this. The regulations themselves for GMP, for good manufacturing practice, these are things like the FDA, which everybody is of the European Union. They've allowed themselves to be sandbagged into the corner by doing this, and now, of course, they're being sandbagged by the I can't say people.
Oh, you can. It's okay.
Well, yeah,
It's okay.
I know.
We're used to it.
I just
We're
find the
used to
whole
it.
thing, absolutely appalling. And that's just one industry.
Yeah, I mean, you're right. I mean, and it's, I mean, the complexity of information systems in general is insane. And then when you put it into close proximity with other complex things like pharmaceuticals or medicine or any large-scale industry like that, whereas lots of processes are important. Yeah, it's very few people will have the expertise in both sides. I think is the big problem, and there's just continual misunderstanding, and also the standardization process is not used to the the rate of change, particularly in a lot of traditional industries. So yeah, it's a big problem, and it will get worse.
Okay, I think let's move on from there.
Yeah.
I would like to continue that debate during panel discussion, but I think we need to move on to the next speaker. So, Karen, thank you so much. Does anyone want a quick break? Yeah, quick 5-minute break, more drinks, comfort break, the restroom division on the other side for this divider here. And then we'll hear from our third speaker, who's just getting mic'd up.
Yeah,
Richard Taylor is the CTO of Critical Blue. Get tweeting, retweeting.
I'm going to talk about software identity. So this is actually kind of one of the things that Barry was talking about. That's why Barry went first. So one of the kind of attacks that you can make against a system is like a spoofing attack. So what I'm going to talk about is a kind of a slightly more lower level nerdy detail. This particular aspect of how you identify software and how that's much more important going forward, and the types of attacks that you can make against systems if you can't be sure what's talking to you. So one of the things that was happening over the last kind of few years is this kind of growth of APIs, so web APIs. So essentially, this is the way that many systems communicate nowadays. You know, REST APIs, JSON data encoding, very, very common. There's this kind of enormous growth of APIs where companies export the services directly through an API. They don't have a website so much anymore. They kind of see it as a kind of API first. This is the way you kind of provide service to your customers. And many mobile apps don't work standalone. Many mobile apps and indeed IoT systems are actually communicating with the internet via some kind of web-based API. Now with that kind of comes the concern about, well, how do you secure these API systems? And you know, there are many kind of technologies and techniques around user authorization and authentication, but the techniques around kind of authorizing the software entities that are talking to the internet are somewhat more primitive than that in general. So I'm going to kind of talk about this in the context of primarily in terms of mobile apps, but most of what I'm saying is very relevant to IoT as well. A good example of this that happened recently, was very much in the news, is Pokemon Go. So this was a kind of huge hit last summer. It was in the news all last summer. You know, this game was released. They tried to stagger the release over different territories just to try it out and to kind of manage the amount of server load, because essentially this is a game that has lots of kind of server interaction. It's truly interactive. There's a global map behind it, running on servers. So they were trying to kind of release this gradually over a period of time, and it was a massive success. 500 million downloads, a huge number of miles walked, etc. But one of the things that kind of emerged very quickly after the initial release of Pokemon Go app was that people were kind of downloading it in different territories, not the original territory they were targeting. They were kind of spoofing their GPS coordinates. And then it kind of emerged this kind of game where people were actually trying to build in map features, because the game originally had some kind of primitive map feature that caused quite a lot of server load, and that was kind of removed in an update in an early update of the app. And then what happened is that people were actually building their own maps, and they became available on the web, so you could basically see a map of where all the Pokemon characters were, and that wasn't the original intention. So what actually happened was that the Pokemon app and the back-end server, they communicate via an API. Now that's not a public API. That wasn't something that's been published. That was something that was private between the app and the Niantic servers. So there was no information in the public domain about how that actually worked. But kind of within days of the app being released, people analyzed what the app was doing and how it was communicating with the back-end servers. There's basically a man-in-the-middle attack, which I'm going to talk about, where you basically analyze the traffic that's going from the app to the back-end servers, and you work out what the protocol is from first principles, which means that then you can build a software agent, an SDK, that communicates just like the app, and basically you can kind of then get the information that's available on the back-end servers directly, and in this particular case, you're kind of building up a kind of aggregate map of where the Pokemon characters were, and while doing that, also generating quite a lot of load on the servers, because you're making many more requests than the average app would. So you're actually increasing the load and therefore the cost, for kind of providing this service. So this wasn't the intention, and then what emerged was this kind of cat and mouse game that kind of occurred over weeks and months, really, where Initially, the app was easy to man in the middle, and then a new version of the app was released that kind of added some more protection to make that more difficult, but that was kind of immediately broken. And then various other kind of protections were put into the API to make it more difficult to build another piece of software that could talk to the back-end servers. But these things were broken within days, and it was kind of this kind of ongoing battle that occurred where people were kind of, the enthusiasts were priding themselves really on how quickly, they were kind of literally working 24 hours. They were priding themselves on how quickly they could work out how the app was making its request and basically breaking it, to re-enable these kind of map functionalities. And then it turned into legal threats, and there were kind of more restrictive mechanisms put in where there were kind of captures put into the app as well to kind of prove that you're a human rather than a piece of software. So this kind of goes back to the fact that actually, even though we have quite sophisticated mechanisms for user identity, in terms of a piece of software identifying itself to a server, it is really quite primitive in general. Typically, if you are kind of a user of an API and you want to sign up to use an API as a software developer, you may have your own users that have kind of a user identity on top of that. But if you want to sign up and use an API that's on the web, you basically go to a portal and you sign up and you get issued with an API key. And really it's just a password. It's a random string of digits that get generated, and that's used to identify your piece of software when you talk to a back-end service. Now, of course, it's just essentially a fixed password, and then you have to build it into your software application. And of course, because it's a fixed password, effectively, that's built into a software application, there is a risk. And normally, if you kind of read the small print when you sign up, it says things like, be sensible with your API keys. Don't publish them. Make sure they're not easy to see or kind of extract from your software system. But the reality is that you have to have that API key in your software in able to identify yourself. So at some level, it has to be there. So there's kind of really two types of software that you need to worry about. There's kind of what I kind of consider to be a private piece of software, which is something which is running on a server. So it's kind of a server-to-server communication, where you have the advantage that you're not actually releasing your software into the wild. So your software is protected by your kind of network security. So if your network security is good enough, then hopefully your software is going to be protected. However, you still need to be very careful, because if you were to accidentally publish your software, then of course your keys become visible. And there have been cases like this where people have accidentally kind of published, they've put their software on GitHub and they've failed to scrub their keys out of their software, and immediately what's happened is that somebody has found that on GitHub or some other kind of open source repository and used those keys. And there's an example on the slide where somebody had made the mistake of putting their Amazon keys. They essentially published their Amazon keys, and then literally a day later they found they had this enormous Amazon bill, because these were keys that basically allowed anyone to spin up various instances of machines. And there are kind of software projects which actually kind of troll and analyze the source code and actually look for things that look like keys, and you'll be immediately alerted if a new key turns up. So there's a kind of an automated attack against that. But in general, that's less of a problem. The bigger problem is really when you have to put your software into the public domain. So if you're publishing a mobile app, then essentially you're publishing your software into the public domain. I mean, it needs to run on people's devices, and therefore it's in the public domain. It's very similar in IoT. There are kind of some code reading protections on IoT devices, but in general, I mean, you're putting your code into the wild. So if you want to keep your keys safe in this instance, I'm talking about a mobile app, there's kind of two attack surfaces you need to kind of worry about. There's the attack surface, which is where your API key is being transmitted from the mobile app to the backend service in the cloud, so kind of in transit. And there is the attack surface where somehow the code is inside the mobile app. So it's the kind of the attack surface where you analyze the mobile app itself. So talking about the kind of first attack surface, which is the kind of transmission attack first, and that was essentially how this reverse engineering of Pokemon Go happened, at least initially. I mean, the way kind of TLS works is that you have various certificate authorities, and they are trusted and they issue certificates. And then you can basically, as an API provider, you can buy a certificate for your domain, and that gets signed by the certificate authority, which allows you to demonstrate to an app that's connecting to it that you actually do own this domain, and it's been signed by this authority. And then on the other side, the kind of root certificates are essentially pushed onto the device, and they kind of represent a set of certificate authorities which are trusted by that particular device. So if you have a device and a back end, and neither of which are under attack, then basically TLS guarantees that the key negotiation that occurs when you start up the connection ensures that any man in the middle who's observing all the traffic can't know what the encryption key that's actually chosen for that session is, and therefore can't see the traffic. So generally that's okay when you kind of trust both ends of the communication. The problem is that the situation we're in is not a situation necessarily where you trust both ends of the connection, because generally if you're trying to analyze a mobile app or maybe even an IoT device and try and extract some information from it, actually the one end of the communication is actually under control of the attacker as well. So if you want to man in the middle the communication between a mobile app and the back-end server, you have the device, you have the phone or the tablet, then what you can do is you can basically place what's called a man-in-the-middle proxy, a piece of software that sits in the communication between the mobile app and the back end, and that basically issues a kind of self-signed certificate and says, yes, I am this thing from this particular API domain, trust me. And of course, normally that wouldn't work because you've signed the certificate yourself. It's not from a certificate authority because you don't actually own this domain. But all you need to do essentially in this scenario is you basically push that certificate onto the device and say, yes, this is a trusted certificate authority. What happens then is that the mobile app will open that communication quite happily, thinking it's talking to the real back end. The communication will occur, but actually all the traffic is being decrypted in the middle, which enables you to see any secret or any key which is being passed across that channel. So if you have a particular API key that's built inside the app, then you can immediately steal it at that point. The way you kind of defend against that is that there's this kind of technique called certificate pinning, which basically means that the app itself doesn't trust the certificates which are pushed onto the device. So it means essentially that the app itself only trusts a very, very specific certificate or particular certificate authority, which means that you can't do the man-in-the-middle attack anymore. The problem with that is, of course, that the code to do that, to actually make that check, is itself just a piece of code and another secret which you build inside the app. So all that does, it closes one attack surface, but the other attack surface of attacking the app is still essentially open. Now, if you look at kind of Android in particular, but also iOS, and I think in the future also IoT devices, there are many, many tools which enable you to take any app which has been published and basically look inside it and to reverse engineer it, to disassemble the code, do all sorts of kind of very fancy analysis that enables you to see what that particular app is doing. You can see that what's in the memory map. In many cases, you can actually modify the code on the fly, so you can actually make modifications to it. You can debug it. You can see what's going on, and therefore you can extract. Generally, you can extract the secrets from the app, which are the secrets which are used to access the back-end service, or secrets which are used to kind of pin it to prevent man-in-the-middle attacks. And there are various tools that enable you to kind of just break pinning, or they enable you to extract these secrets very easily. And then it's really a kind of it's down to how well you try and conceal the secrets inside the app. Ultimately, it's very difficult to win at this game, but you can actually conceal the secrets in slightly more clever ways and kind of create them dynamically, and you don't simply kind of put them as a string inside the app in order to extract it directly. But if you look at many apps, they actually essentially just have the secret inside the app. It's very easy just by doing this kind of strings analysis to see those secrets. And the reason why this is important is that it means that in any communication of a mobile app to a back-end service, one of the attack surfaces that's not looked at sufficiently really is this attack surface of the app itself. So if you look at kind of a banking example, you've got lots of security around the network of the bank itself. And then there's the kind of transport layer, HTTPS security between the mobile app and that back-end API. So, you can't, as I was saying before, you can't simply kind of decrypt that traffic. And if you look on the kind of user side, there'll be all sorts of kind of user authentication mechanisms, maybe biometrics, second factor authentication by text message, all sorts of technologies which are used to identify the user. The level of kind of protection inside the app itself is much less. And if you kind of look at kind of history of kind of online banking, many of the attacks against banking have in the kind of web era where people have been using kind of browsers to do mobile banking, a lot of those attacks have been viruses which have basically modified the browser and misrepresented what's going on inside the browser. So you might think you're kind of transferring money to person A, but in fact, behind the scenes, the app is actually modifying what's being transmitted to the bank, and you're actually transferring it to person B and being kind of tricked into authenticating that transfer. So if you can modify the app, then you basically control the complete presentation of what's going on to the user, and also you're controlling what commands are actually being sent to the back-end API. So this is a kind of an important attack surface. And it's not necessarily that difficult to kind of socially engineer someone into installing a modified banking app or installing some other app which is actually a malware which can then kind of obtain root privilege on your mobile device and then modify another app. So this is a kind of quite a concerning attack surface for all sorts of things, but obviously kind of something financial is definitely of high concern. So there are some better approaches to kind of secure apps. They're not widely enough adopted, but there is a kind of increasing move for kind of particularly sensitive apps for these approaches to be used inside. There are kind of pure software approaches like white box cryptography, which essentially means that you mathematically and code level obfuscate what's going on inside an app to make it much more difficult to work out how fixed keys are being used or what keys are actually inside the app. The difficulty with that is that it's sometimes possible to kind of lift the entire thing out. So even though what's going on inside the computation is obscure, if you can take an app and you can lift the whole thing out and use it in your own modified app, then you might still be able to use that kind of cryptography without really understanding what's going on. So it kind of suffers from the fact it's quite, it's transportable. Another technology which is an excellent technology in terms of protection are kind of trusted execution engines. So most hardware devices, pretty much every mobile phone and many IoT devices actually have a kind of secure area for execution where the code that's running in this kind of secure area is secured at a hardware level, which means that other software running on the system really can't observe what's going on. It's very secure. The difficulty with it is because it's so secure, it's also quite difficult to provision because you have to be sure that that software that's being put into the kind of secure execution area is itself not malicious. There has to be a kind of fully signed signature authority mechanism to actually provision that inside the device, and those mechanisms aren't as well developed as they really should be. And there's another area, which is the kind of area we're working in with mobile apps, which is what we kind of term software attestation, where basically rather than have a fixed key inside a piece of software, you actually do a kind of dynamic measurement of the software, and you basically measure what the software is at a given point and prove that it is actually the correct software and it's not been tampered in any way. So this is obviously important for IoT as well. I'm talking about this in kind of the context of mobile apps, but the IoT question is fundamental in the sense that if you have multiple sensors on the edge of a network, and maybe those sensors are feeding back data, gathering data or feeding back data via an API, how can you be sure that those are actually the sensors that are providing that data? How can you be sure that that data is real? If you can work out what the protocol is, and you can work out what keys or what other mechanisms are used for those software entities to authenticate themselves, then you can basically spoof the data. And there are many applications in traffic systems and medical applications where if you can spoof the data, then you can have quite devastating consequences. There are some really good technologies, especially in the IoT space, that kind of protect. There are technologies which are kind of based on having a kind of private key and a certificate for each individual device that's kind of put there at the time the device is manufactured, which allows you to tell which particular device it is, and because it's a private key, you don't know what that private key is, and therefore you can't spoof the communication. And it's done in such a way that it's got hardware support, so it's a bit like a trusted execution engine. It's basically a kind of private area inside the hardware that you can't read back. So it's kind of provisioned at the time device is built, and it's not easy to then read back. Although it does imply that on the other side you have to have a database of all these keys. So you then have to worry about, well, how are you sure that this database of all these keys is actually secure? So in summary, I mean, basically, if you publish anything on an API on the internet, even if you didn't intend it to be, you have to basically consider that to be accessible to anyone, and you have to consider the possibility that someone will reverse engineer the protocol and whatever mechanism you're using to authenticate. And there's much discussion about kind of user authentication and authorization and many techniques around it, but you have to draw the distinction between the user identity and software identity. It may be that you have a completely valid user, but that valid user has been tricked into using a piece of malicious software. And there are technologies emerging that are not widely used enough to actually kind of make these systems more secure. And I think this will kind of be increasingly, as we kind of secure other aspects of the internet, this kind of software identity issue will increasingly become an area of kind of hotter interest. So I just want to kind of publicize our Twitter handle, CryptBlue. So we kind of tweet about all things kind of security, IoT security, app security, and everything to do with the kind of industry, especially kind of looking at the kind of technology side of it. And we also have a blog. We just published another blog article today, which kind of is talking about IoT security and the relationship between IoT security and OAuth, which is one of the kind of standard technologies that's used for kind of user authentication. Okay, thanks very much. So, any questions? Yeah, that's a really good question. I mean, it's not an area we currently deal in with. We're looking at mobile apps and sort of higher end IoT systems. I know there's a lot of interesting work like COAP protocol. There are a lot of interesting protocols which are kind of emerging to deal with kind of security with kind of lower end devices. but yeah, I mean, certainly if you have limited compute performance and certainly with limited byte transmission ability on these kind of low power radio networks, that's difficult, because then you have to basically encompass your identity in a way that is not visible to everyone in a small number of bytes.
I have seen some approaches where you can spread out things like the keys. So one issue you have with IoT in particular is a lot of devices have very, very good handling for the black key idea, where the keys never visible in software ever, and the hardware acceleration is rubbish. So then yes, you can sort of spread out the key because there's multiple things and you can roll up the winner. So yeah, that kind of approach all really well.
Any other questions? Okay.
Okay. Excellent. So this is the part of the evening. How are we doing for time? We've got plenty of time. Good. Now we can either do seats or sofa. It's going to be quite cozy. So, Barry, Martin, do you think we can get 4 on that? What do you reckon? Okay, we're going to get a little bit cozy here. Take a seat because we're going to do the Q&A thingy. I'll tell you what, I'll sit here. Guys, take a... Let's see, actually. Yeah, I think kill the AV. Alright. Do you want to watch that laptop over there? And we need to bring it in. Whose laptop is that? Are we good? Are you sure? Okay. Alright, so I try to process as much of that as possible. I'm not technical, firstly, disclaimer. Secondly, I'm tweeting and I'm a guy, so I can't multitask. I wish I could. And it's actually a shame when I'm doing a lot of that online stuff. I find that I'm missing portions of the talk, and I often have to go back and watch the live stream on YouTube later to get all these insights and golden nuggets of information. So I think let's talk about privacy, and I think privacy and security kind of do so often go hand in hand, don't they? But without getting too much into the GDPR conversation, because I think we could talk about that all day, it's more about, I think that let's sort of discuss that balance between what is providing enough of a kind of a zone of tolerance in terms of security without really pissing off the end user. And this is something I think that needs to be resolved, and how can we tackle that? How can we solve this issue of there's biometrics, so there's voice now, retina scanning, fingerprints. I mean, all that's all very well and good for human to machine interfaces, but increasingly we're talking about machine to machine. So there's no human interface built in at all. That's the biggest concern that I have when you've got machines that are managing some mission critical tasks. Maybe they're running a dark factory or an oil rig or a nuclear installation, and there are actually people who are increasingly being taken out of the loop. How can you prevent those sort of spoof attacks? And is that something that is a genuine concern? Are we worried about that? Let's talk about machine-to-machine security, specifically relating to the AI and the automation of mission-critical assets. How about that?
Touching on that, as well as what everybody's been speaking about, are any of the speakers, or indeed anybody here, aware of joining software that allows the user to join their own ID within the software? The reason I say that is, even though it's machine to machine, there has to be a human involved somewhere, perhaps the developers to start it off, or whatever. So by the time you embed a personal ID, you know where attacks are coming from. Do you know of any software that's doing that at the moment? Actually allowing from the user ID to go in, which allows tracing. And that's on the basis that when a user has put their own ID, and I don't mean an ID in a human form, but I do mean one that they use everywhere, people are less likely to try and invade systems or start the attack surfaces like for DDoS or for spoofing. So
What do you think, Barry?
Yeah.
You seem very keen to answer.
Yeah, there's a couple of I mean, in terms of IoT, in terms of organizational ownership, a person being a corporate body, increasingly a lot of devices will have this capability where you can they'll be identified as that device from that developer and running this software specifically. So you can kind of track it out to that degree. But usually that's not the problem, it's when the spoofing happens, when you come up and pretend to be that device. So that's the tricky bit, is being able to get that repudiation where you can sort of say, no, that was you, and we can prove it was you for these reasons. That's very, very hard, because despite the fact there's lots of, in theory there's a lot of work around digital signatures, and maybe even mapping them back to biometrics and things, there's no standard, we don't all have a barcode. So there's no uniform way of doing that. So in general case, you can't, particularly in terms of consumerism, when you have a product and there's a billion of them out in the marketplace, you don't have any idea who's got it, and there's no way of saying who has it. All the best you can do is to say, I know that that is a genuine device talking to my service, and I know it's in its genuine condition, non-tampered with. Therefore, it shouldn't do anything bad. The only way it can do something bad is someone's found a way to make it do something bad by putting stuff into it through legitimate channels. So that massively reduces the attack surface. But I mean, one of the things that's secure is you can never eliminate it without falling over into the absolute knowledge kind of problem with privacy. You can probably get an absolute secure system if you know absolutely everything. I think that's kind of terrifying. So
there was an interesting project from Google where it took a different approach to this, where they used multi-factors in terms of authenticating. In this case, it was user, who was at the keyboard. I think it has data protection implications, because in terms of multi-factors, it was looking at keystrokes, patterns of behaviour, moving the mouse. But the interesting aspect of it was the security level was variable. So depending on how confident it was that you were the actual person logged in that machine, it would remove privileges. So as you got less confident, start removing access to servers and things like that.
Right.
So I think that kind of multi-factor authentication is an interesting approach. How it would be applied to IoT devices, I don't know, but I thought it was an interesting way to look at it.
Again, let's project forward 5-10 years. So we've got a certain percentage of driverless cars. Our smart homes are running themselves. The aircon, the lighting, the thermostat. Should we be concerned about these devices being hacked? Again, going back to sort of mission critical civilian assets, so transportation systems, like I said, driverless cars, aircraft navigation systems, and as autonomy and AI starts to become an increasing part of our everyday lives, again, what can really, should we just sort of take a step back? Are we being irresponsible by pushing forward all these technologies before we're actually ready to embrace them? The technology is not being embedded at the heart of everything we do. Is Elon Musk overstating the concerns, the worries about AI and automation? Is it paranoia, or is it all fine and everyone's confident that it's heading in the right direction?
Well, I think in terms of consumer devices, as Barry was saying, it's pretty shocking. And unless there is kind of much more oversight and required regulation, I'm not sure I see the situation getting bigger immediately.
Okay,
regulation.
let's talk about, I mean, for example, kids' toys.
Yeah.
The amount of times we're hearing about kids' toys being hacked. Not even hacked, just being shipped with no security. And, that is really creepy. What can be done? Is it a governmental, that you penalise the companies and then fine them, and there needs to be a kite mark on every product before it's shipped?
I mean, there's already these mechanisms in place. I mean, the rules about what can be in children's toys is the main reason why most children's toys are not suitable for under 3s, because it's so stringent. So this is already in place, and you can just add to it. Yeah. Our problem is the regulation keeping up with technology.
Guidelines like OWASP, or
Are
these companies getting sued when they
wherever
breach?
you've got guidelines,
Okay.
you've got regulators like the data commissioner.
Right.
Where you've got regulators, they're more than useless. 9 times out of 99.
Because they've got no
99,000
teeth,
times.
or what's the problem?
They just don't do it. People don't have the confidence to go to them. When they do go to them, they are slow, they are reticent, they tend to be inscrutable and therefore not transparent towards ordinary people, which circulates right back to the confidence. So it's only the big organisations that tend to use them, unless you're somebody like Max Schrems, who's got a PhD in law and is quite happy to take on Facebook.
But how about
So
class
there's a
action
problem.
lawsuits? That, I mean, it's happening against Fitbit,
That's my
but VTech in the States, I mean, I think that allegedly they were one of the largest infringers when it comes to kids' toys.
That's my
I think Mattel have also been
I'm
implicated.
waiting for the
Have they been
case.
sued or no, or what?
No, but I think the bigger problem is the fact is that these companies who are not used to this technology, not used to these internet devices, not used to the fact that there needs to be the security, and they're running in to try and get the next product out quick enough with these new ideas that are coming out, and rather than security is the afterthought at the end of the day.
But why don't they employ the right people in-house? Why don't they go to companies
They
like
don't realise
Crystal
they need
Blue?
to. I think that's the issue.
Well,
They don't realise that
what?
the
I
risk
mean,
is there.
really?
Well, commercial
It's not
reasons
rocket
as well.
science. Okay, it's the expense.
It's-
So therefore they're not going to do it because it's expensive, unless there's a very strong.
If there's 2 competing products and one takes the extra time and expense to implement security,
Right.
the other product got to market and has paying customers beforehand.
Okay.
So unless you have something like regulation saying you can't take an exploitable product to market, then
Or end user awareness. To say that product is dangerous, don't buy it. Mum's net or whatever.
You need some kind of regulation.
These manufacturers will get a bad reputation.
Reverse market force.
Okay, so it's either regulation that they know something bad is going to happen if they ship irresponsibly, or their brand is going to be tainted because consumers are going to rebel. But right now there's just a lack of awareness.
Yeah, there's not. I mean, the market is not a good differentiator for this. When you
Okay.
look at the success of Facebook. People are very, very happy to just give all their information to everybody, and large corporate business. They just
And the
are.
regulators are always one step behind the technology.
Exactly, yes.
And so that's the main problem.
So consumers aren't really concerned about their own privacy.
Yeah, no, because they don't realise.
They don't understand it.
They don't understand it.
Yeah.
And the main,
I think that's
I think
true.
the main thing for data is anyone who's got a smart home or a smart car or a smart cat or a smart dog has certain things which give themselves away. So somebody might say, well, okay, anyone who's got a smart home likes Cadbury's chocolate buttons or something like that. And that data can be used to target advertising to these sort of people. And that's whether that's a worry or not is neither here nor there, but that's part of the
So
problem.
the average consumer has no concept of how their data is being
Yes.
captured.
Yeah, and even if they do, it's quite low on the
Okay.
on the radar in terms of things.
So
Yeah,
something
right,
really
right.
bad is going to have to happen before people can, and it goes mainstream.
Yeah, and if I just go back to that thing I was saying before, there are a huge population of children now who have not been vaccinated against measles because of what happened with that sort of thing. And there are going to be people with the long-term complications of measles which they have for the rest of their lives. And because their mothers thought they would get autism by having this vaccine. people just do not understand this sort of thing. So how on earth are they going to understand the sort of very small things that affect us in our everyday lives?
Okay.
Just what brand of chocolate buttons that you buy, or something like that.
That is actually a counter-argument, because I'm saying that people don't care about security and stuff, but actually that's the counter-argument. As soon as you start a scare story, suddenly everybody does care. So it's maybe that's what we need to do.
We were talking about that, that car getting hacked in Wire, do you remember?
Yes.
And there was a huge backlash to say that's total garbage. The likelihood of a car actually getting remotely hacked is so infinitesimally small that that actually was kind of nipped in the bud. And in fact, what we need is more scare stories to generate more fear. Healthy paranoia, perhaps, amongst consumers to pressure the OEMs into embedding better security into their connected devices. Real quick, sorry, I know that you were.
But it's funny to say, you've got things like the big TK Maxx hack that happened a few years ago. There was a few other big companies hacked in the similar manner as credit cards and data was lost. And the share price went down for about a week and then went back up to normal.
Just bounced, yeah.
As if it didn't matter. And the people were still shopping there as if it never happened. Because people don't understand what's going on. Even if they did understand it, it's not directly in front of them, it's not their information, so they don't know more what to do.
So it's the boiling frog
so they just
syndrome.
carry
People,
It's basically we've got about 1% of the population going, this is a problem, we need to deal with it, and the other public is going, I don't understand it.
Or is it just a case of like this is an accepted risk among society?
until it's too late.
So I think it's worry about
it. I mean, 300,000 people die every year in car accidents.
Yes.
Across the world.
Other things to worry
Totally
about, that's it.
So,
It's just the parallel earlier about cars and car safety. Thousands of people die on the roads every year. For years and years and years.
The point Barry just made, yeah.
But it took like a group of people, like Ralph Navy, so it took somebody to kind of be a focal point to kind of change the law. But then when he said about, kind of cost pressures, but companies like Volvo actually saw that as an opportunity. And that was a sales point. If you want a safe car, buy a Volvo. And a lot of the technologies that they pioneered, they're standard on every car now. So I don't know, I think it's going to take a long time, but eventually it can kind of get into the public consciousness, and then there's an opportunity to address it. But I think lots of bad things are going to happen.
It's quite worrying as well that we seem to be going in reverse, where in the States, ISPs can now sell your internet history, and you have no, ever jumping on a VPN, you have no control over that. And so instead of
even if you're on a VPN now,
instead of legislating against, they're permitting it. So that's, I think, quite worrying.
Well, what you said, that applies to everybody else except the people in the States, isn't it? The States gather everybody else.
No, that's for spying.
Can't do it in
that's prison,
this is worse. This is worse. So that's for bulk spying. So they've actually made it legal now for internet access companies, for ISP, to sell your internet history.
This is commercial,
Yeah, it's horrendous.
not even sort of citizen security. We're getting beyond the Snoopers Charter or whatever it's called in the UK. So this is not keeping you safe; it's to make their money. Sorry, go ahead.
I was going to say, was it local governments, UK government, if you had kids' toys that just burst into flames and scalded children, you'd have government all over it straight away. It'd be consumer protection pure and simple. So is there not a need for some sort of BSI countermark on this connected cuddly toy will not be sending a picture of your kids to Russian foreign makers or whatever it is? Is there not a role for government in that? And as a public service kind of society kind of thing?
Yeah, I think it's because we're dealing with an intangible. It's so difficult for the average person to get their head around. It's a little bit like mental illness.
Sure.
A lot of people say that if you're involved in a car accident, your boss, for example, conceded that you're physically, beaten up.
Yeah.
Whereas if you are mentally beaten up, your boss may have, little sympathy for you because, where's the evidence? I don't understand where the problem is. So in the same way that, if something sets you on fire, you can physically see the burns. But what is the equivalent when your privacy is being breached? I suppose you could be compromised, blackmailed, and so there's, again, it's psychological damage as well as financial damage, but people can't really kind of relate to that in the same way.
But,
How do we solve that problem?
Universal solvent. My limited exposure to our learner friends is that money is the only compensation. It's the universal solvent. And, someone breaks your leg, you can't really break your fingers, give you lots of money. Perhaps.
Well,
perhaps maybe your friends.
depends which country you're in. Let's not go there.
We've not achieved an era. We now have these ethical hackers who are trying to make sure these systems are secure, finding out exploits, reporting these to people. But is there not a disconnect between the people developing the products and the people who are saying well, dealing with security issues? And there doesn't seem to be a connection between the two directly to deal with those issues, as it were.
I mean, it's to do with engagement, ultimately. And it's to do with different motivations. Because if there's no, ultimately it's business trade-off. So you're in business to make money. You make money by selling things, and you can develop them as fast as possible, new features into market, blah, blah, blah. There's no penalty for it not being secure. Why would it be secure?
So do you think there might be a backlash where people suddenly think, okay, if it's, the smart TV spying scandal that was exposed by WikiLeaks, it's a well-known South Korean consumer electronics brand, where there are people now who are going to think, if I'm having an intimate moment or a particularly controversial conversation about my political views, for example, let's unplug all our connected gadgets. I'm aware that I'm within, monitoring distance to Siri on my computer, OK Google on my watch, and Alexa. So there are 3 different companies who are technically monitoring, theoretically, everything I say.
People are specifically buying devices to bug their homes.
Yeah.
So what is there going to be a backlash where everyone starts going analog again? And then they go out and try and find that they can't actually buy a non-connected gadget, and so they have to start going on eBay and start buying factories instead of email.
What are the sales figures for Alexa?
High, very, very.
There was an incident with Alexa just a few months back where a young girl, the parents had enabled one-click buy on Amazon Alexa. So this little girl, about 7, 8 year old, said, right, I want a doll's house. Alexa, buy me a doll's house. So it bought her £140 doll's house.
Well, that's
not the end of the story.
That was broadcast live, right?
And then they broadcast it live on Fox News.
And thousands of people.
Thousands bought.
Do you want to know who's got Alexa in the room? Have you noticed now that when someone says Alexa on the Amazon Alexa TV commercial, Alexa did light up and start responding? Now there's some kind of over-the-air filter. Because I've noticed in TV spots, when they do talk, say Alexa, my Alexa is no longer responding. So they must have realized as a result of that there's some over-the-air lock, analog, through the analog hole. I don't know how that... There's a company, there's a technology called Chirp or something that does that. They can embed cookies over the air from the microphone in your connected gadget to the TV ad that you're watching.
Yeah, the idea has been using ultrasonics to do that for the last few years.
Ultrasonics.
It was kind of concerned that at one point that Facebook might be listening to which TV ads you're listening to at a particular point, and then will show you kind of appropriate content.
So do you remember, Tim? For 1 week, I did an experiment because I was paranoid that Facebook was monitoring. Because when you agree to the terms of the Facebook app, it has access to your microphone, your camera, your hard drive, and so on. So I didn't tell anyone what the brand was. It was just a random brand that I would never buy. But I started saying Harley Davidson to my phone several times a day for a week. I started seeing Harley Davidson ads on my newsfeed, and actually I didn't weirdly. I was convinced that I would, but I didn't.
Supposedly they were listening to when you were posting the message.
But that is the counter
When you were
argument.
posting the message, they were checking the mic at the same time.
They're ahead of the game, and they knew not to show me, because otherwise they would have been busted. Yeah, exactly. Yeah, this guy. Don't waste your money serving those ads. Show him, a charity shop ad or something. So, have we covered all the questions? Because I think we need to sort of wind things up and have a little bit more networking, a few more drinks. What's the hard stop? 9 o'clock? Because you guys need to go home at some point, I'd imagine.
No particular hard
Unless
stop,
you
is it?
sleep under your desks,
Yeah.
perhaps you
Of course,
do.
yeah.
Yeah.
Well,
Hard
we've got
working
this
guys.
much beer, we might.